Okay, let's look at number 9 from the integral calculus test. Number 9 looks at first to be more difficult than it is. We've got a fraction equaling a fraction. And it looks like it's going to be a bit of a mess, but it's not too bad because all we need to do is calculate the values of a, b, and c. So here, you notice the denominators are quite close. Let's just make them common. So then I'm going to end up with x squared on the left, and here we're missing 1 plus x squared, so a times 1 plus x squared, a times 1 plus x squared, and then bx plus c times 1 plus x equaling x squared. Expanding that out, a plus ax squared plus bx squared plus c plus cx. Now it's pretty simple because your constant a plus c is going to be nothing. Your coefficient a plus b is going to be 1. And here you have b plus c equaling, again, 0. Right? So you have these 3 equations. From those, you can determine that a is minus c, or c is minus a. You can then put that into the second one here, and you can determine that a equals b. Once you know that a equals b, a plus a equals 1. So 2a equals 1, so a equals 1 half. Once you have a equal to 1 half, 1 half plus 1 half is 1, so b is 1 half. And finally, this is 1 half. C is negative of a from here as well, so it's negative 1 half. Okay? So we've calculated the values of a, b, and c. The nice thing with the IB is it's hints, so you've got part B. Even if you couldn't quite get this, you could make up some reasonable values for a, b, and c, and as long as they are not making the problem too easy, you can get some follow-through. But we have the values, so we're okay. So we put the values in to the here, because you can't integrate this thing. Let's do this one. This one's easy. Okay? So a is 1 half. So here, that's where this 2 comes from. And then b is 1 half, and c is minus 1 half. So 1 half minus 1 half, 1 plus x squared. Then, factoring out the 1 half, the integral of 1 over 1 plus x with respect to x plus 1 half comes out from the top. You get x minus 1 on the top, 1 plus x squared on the bottom. Then you have this, which you can break apart to x over 1 plus x squared and minus 1 over 1 plus x squared. And then we can bring in the lns. So the first one here, 1 half ln of 1 plus x. Here, 1 quarter ln of 1 plus x squared, because here the derivative is 2x, x over x cancels, you have another 1 half that comes out to give the 1 quarter. And this is a special one from the formula booklet, 1 half of arctan of x. Okay? Then we move on, and you are given now that at pi over 4 when x is equal to 1. So we're going to find the other values of the constants. All we need to do at this point is put in the value pi equals 4 equals, and everywhere there was an x, put a 1, make a substitution. Simple method mark there. Then we just evaluate. Ln of 2, half and a quarter, 3 quarters, minus 1 half arctan of 1. So bring in the special triangles. Which value has arctan of 1, pi over 4? Therefore, pi over 4 times 1 half minus pi over 8. And this gives the 3 quarters, like I said, and equals pi over 4. Solving, pi over 8 comes to the other side, adds to 2 pi over 8, 3 pi over 8. And then you end up with 3 quarters ln 2 comes over, becomes minus, and you have your constant of integration. And